A meat grinder, a clockwork mechanism, even the human heart. What do all these things have in common? Today, we'll talk about the mysterious Archimedean spiral, which was discovered thousands of years ago but is still at the heart of modern technology. The Archimedean spiral is one of the most beautiful and useful discoveries in the world of mathematics and engineering. It is not just a geometric figure, but an expression of the high intellectual potential of the ancient world. The story of its creation is as follows. The Archimedean spiral is named after the great Greek scholar Archimedes, who lived in the 3rd century BC. Interestingly, this curve may have first been studied by his friend and mentor Conon. However, it was Archimedes who described and proved its mathematical properties in detail, because in his famous treatise on spirals, Archimedes specifically mentions his friend and mentor Conon of Samos. Archimedes himself emphasized that it was his friend, the astronomer Conon of Samos, who first discovered and studied this spiral. However, according to the popular science film Archimedes, Lord of Numbers, when the scientist was returning to Syracuse by boat, a flood began and the boat started filling with water. In other words, the boat began to sink. While bailing out the water, this idea came to him. The mechanism is very simple. If you place a helical screw inside a pipe and set it in motion, the water rises upward. The scientist described this form in detail in his work titled On Spirals and brought it to life. The mathematical essence is as follows. The Archimedean spiral is a line along which a point moves at a constant speed in a straight line, while this straight line itself rotates around the center at a constant angular velocity. On vinyl records, the grooves have precisely the shape of an Archimedean spiral. This ensures the needle moves evenly. This is not just a theory, but an invention that has made a tremendous contribution to the development of humanity. What is the place of the Archimedean spiral in society and in practice? The most famous device created based on the Archimedean spiral is the Archimedes screw. In ancient times, this device was used to lift water from lower to higher levels. For example, such devices were used to irrigate fields from the Nile River. And what about springs in clock mechanisms and various flat springs in instruments? They are made in this shape because it helps distribute energy evenly. Pumps, as well as spiral pumps for transferring liquids and gases, are based on the geometry of the Archimedean spiral. Today, it is precisely this fundamental principle that underlies the successful operation of all modern augers, household meat grinders, and powerful drilling rigs. Another proof of the widespread presence of this spiral in our lives is that devices operating on this very principle are used during surgical implantation of artificial hearts. In both architecture and design, the decorations on the tops of columns in ancient Greece, as well as modern spiral staircases, in many cases are based on this mathematical model. Although it was discovered thousands of years ago, it still remains at the core of the technologies we use today. So what is the scientific significance of this philosophy? The Archimedean spiral helps humanity understand dynamic geometry. Before this, geometry mainly dealt with static forms, circles, triangles, quadrilaterals, and so on. But Archimedes introduced the concepts of motion and time into geometry. In summary, we can say that the Archimedean spiral is the harmony of nature, mathematics, and technology. In drafting, it is constructed as follows. The center and the 0 point are marked, after which the x and y axis, that is, the horizontal and vertical axis, are drawn using rulers. Through the 0 center, we draw a circle of arbitrary radius. This circle is divided into several equal parts, 6, 8, 12, or 16 parts. As we wish, we divide it into 12 parts and mark these equal divisions on the circle with numbers from 1 to 12. In exactly the same way, starting from the center of the circle, that is, from this 0 point, we divide the radius, the distance from the center to the circle, into as many equal parts as we divided the circle itself, regardless of how many parts you chose to divide it into. There are many ways to divide it. There is no need to study this. You already know this well enough. And we also label these parts as 1, 2, 3, 4. Now, placing the compass at the zero center and setting it to the first of the equal parts marked along the x-axis, we draw an arc. Just pay attention to the types of lines here. Either use a different color or choose the types of lines yourself or make them thinner. We take 1 point, and what do we do until it intersects with the one on this circular line? We continue. We do the same with 2 points and with 3 and again with 3. And now with 5 points. Here, pay attention to one more thing. Here on the 5th one. We show this on the 5th line. These corresponding points must be marked on the main points. You can use a Roman numeral 5 or 5 dashes. That's it. What needs to be done? You need to mark all 12 points you have found. Our student marked only 1 because he already has experience, so he won't make a mistake. But you might make a mistake. That's why it's better if you mark all of them. During the initial training, we show the 11th point once again. This 11th point intersects with the 11th line, and you mark it as the 11th dash or Roman numeral 11. Then connect the points you found with a smooth line using a template or a flexible ruler. In this way, we gradually get a very beautiful, even and elegant Archimedean spiral. See you in the next lessons. Stay healthy.